Hello and welcome to the 8th installment of the ChessTDD screencast. As has become the custom, I am going to start by deleting old accomplishments and focusing mostly on new ones. So, with that in place, I'm kind of looking at what I have to do here, and I see the task that I want to do in front of me. And what I've decided, as mentioned in the actual text of the post, is that I went into this session knowing already what I wanted to do. I wanted to create the king class. That seemed like a nice, easy thing to do. I'd written bishop, I'd written rook, and for those of you that play chess, you'd know that a limited subset of the combination of those two things is going to be king. You can move one square either diagonally or adjacent. So this seemed like a natural place to go. And something that I'll say is at times you'll sit down for a programming session, test-driven development, or however you do things with sort of very discrete goals. And like I have here, and sometimes you'll sit down with very nebulous goals. You know, I want to make this thing better, or I want to get some stuff done. I would encourage you, when you have nebulous goals, to turn them into discrete goals. So all of your tasks should be as simple as, hey, let's make a king, and let's get it moving correctly. That's always a nice kind of goal to have. Another thing you'll notice as I kind of get started with the familiar setup here, or maybe you noticed it, was I used a keyboard shortcut to get rid of some of the usings up top. That's to try to keep the warning bars on the right side of the screen as pristine as possible, because I like the little green thing that lets Code Rush's static analysis lets me know that I'm doing things right. So one thing I would offer as sort of an oblique encouragement is, when you find yourself doing something, if it involves the mouse a lot, go out of your way and maybe look at your tooling and see if there's a way you can create a keyboard shortcut to do it. If it's something you do a lot, that's going to save you, a second here and there, but those seconds add up and you feel faster and more productive. So that's the end of the proselytizing that I'll do for methodologies and approaches along those lines. Getting to the code, this should look familiar by now. There's a nice pattern here of what I've been doing, which is I am going to declare a class that doesn't exist. I'm going to make it exist. Then I'm going to declare a method that doesn't exist, and I'm going to make that exist. Now, in the spirit of test-driven development, the simplest way, I think, to make this method exist, you see I briefly said, okay, let's go declare the method, but I thought, you know what, let's implement the abstract base class piece, and doing that will actually force me to implement this method, and I'm floundering around with the IDE tools to get it to do that. But to me, this is actually kind of a subtle and interesting thing. We're talking about the simplest thing possible. Well, that right click was fairly simple as opposed to typing out the method. Now it's not passing because of the exception, but if I go in here and get this to do anything that's not throwing an exception, now I'll go green. And my apologies, I was flipping back and forth here. I don't remember. I coded this up about a week ago. I don't remember why I was flipping back and forth, but I believe I was referencing probably the semantics of the tests in the last one I did. So now what I want to do is I want to make good on the claim in the test method name. So I want to test the moves collection to see if there's one that has an x coordinate of 1 along with a y coordinate of 2. The expectation here is that this will not be the case, and there it fails. So this is another kind of TDD standard sort of thing where I can go down and say, well, I can get this to pass pretty easily by just returning x1 and y2 as a dumb implementation of this. And I'm going to have to do yield return because this is supposed to be a collection. Another thing that I'll add kind of as this goes along in relatively predictable fashion, since you've seen this before, and this is one of the easier things that I'll be doing here, it's, I think, worth mentioning that when it comes to the idea of doing the simplest thing you can to get a test to pass, it doesn't always, as I mentioned, mean, knocking out a line of code. It can mean, the right click I did. And there's also an element to this where simplest thing is really kind of geared towards your productivity. So simple is subjective. It's sort of in the eye of the beholder. Maybe for you it's simple to write, an entire for loop, or to do some kind of larger thing, especially if you kind of have a good picture of where you're going. And maybe sometimes the simplest thing will be to do yield return, a hard-coded board coordinate. Really, in my opinion, this is kind of something that will vary for you over the course of time. And the idea of the simplest thing is to prevent you from overthinking, to prevent you from getting away from the scientific method style approach of test-driven development, where you start to do a whole lot of things without knowing and measuring the outcome. So if you're moving along smoothly through red-green refactor and everything's going well, maybe you can bite off a little more as the, quote, simplest thing. But if you start getting ahead of yourself and start making mistakes, you probably need to make it simpler. I don't know if this is a strict adherence to the methodology, or if it's a bit of heresy on my part, or maybe it's just a pragmatic approach. But this has been my experience, that sometimes I can be a little more complex than other times, where I might just be returning something dumb every time. So I thought that's worth mentioning. Your mileage may vary on that count. And one thing I should probably mention is that if you're going to be taking that approach, do it once you're experienced. Go through, really do very simple things when you're just learning this for the first time, because you probably want to have a good mastery of the practice before you start varying and bending the rules the way that somebody who's experienced would. So anyway, to get back to narrating what I'm doing here, I had this notion, now that I have this concept of diagonals going here, that, hey, I wrote this radial diagonal method on the bishop class, so what if I were to pull that up into the base class and then pass something different to it, or use it in a different way, like just limit it to one space, the way it would go for a king. So this, off the top of my head, is a way to kind of go about satisfying this. I want to say get radial diagonal from starting location with a radius of 1. And hey, that looks pretty good to me. We've got 2 passing tests. Now I can write another test, and I could probably have actually deleted that board coordinate. So now I want to tease this out a little bit more and do an adjacent square. So this is great. We've handled all the king's single directional diagonal moves, but we've done nothing for the king's adjacent moves. But for some reason, I always rate that next test before I remember to do my refactoring. The standard initialize pattern that I do here of instantiating target in the initialize method, and then eliminating that instantiation line from each of the tests. What happens is I get to the third test, and I think to myself, man, I don't want to do that anymore. One of the things I do, I've probably mentioned in previous screencasts, is I sort of force myself not to copy and paste, which makes me suffer the pain of typing things out. And as I'm suffering that pain and experiencing it, I realize that I'm duplicating and that I should probably abstract somehow. So it's a way to kind of use pain to my benefit and force me to write clean code. It definitely helps with ruthlessly eliminating duplication. So I'm going to establish the default board size again to get rid of these case-by-case magic numbers. And that's a good amount of abstraction there, because with the actual 1s and 2s up there, those are part of the actual documented test conditions, so I don't really need constants for those. So now I can skip a line, and I can pass the board coordinate as specified in the name of the test method, and then I can also assert that I'm getting back something matching the expected return value here as well. So I'm going to do this, and I'm going to expect it to fail, because we are only handling this radial diagonal condition, not any kind of radial adjacent condition. So now this is sort of an example of what I was referring to before. I have this method, get radial diagonal. Now the simplest thing I could do here, one might argue, is just to do a hard-coded return value of the coordinate that I just specified, but I'm going to skip that, because I think that it's pretty simple in concept to take a slight variation on what I've done above and kind of in one fell swoop define the concept of adjacent here in addition to diagonal. So to me, this is really a sort of natural extension of the thinking. So, we're going to wind up writing a couple of lines of code here. because at first I'm just going to do these two cases, not get too far ahead of myself, but, I could have just done one of the cases, or I could have just hard-coded something. So I'm not going to do either one of those. I'm going to actually define this method in the abstract base class. And for me, that's fine, because I have a pretty good feeling that this is going to go well, and it's going to move me along in my development, and I'm still, going with the red-green refactor cycle, so it's kind of a subjective thing that you'll get used to as you go along, whether or not you're biting off more than you can chew. So there I have green, and I also, while I was at it, cleaned up that hard-coded value I should have. All the tests are passing, and life is good. So now I know that what I haven't done is I've kind of done moves in the positive direction for the adjacent coordinates, over one and up one, but I haven't done any moves in the negative direction, so I know I'm going to have to go in and do that too. Oh, and now as I recalled, since everything was green, I decided to do a little cleanup here, and instead of iterating over two separate calls and having two separate bodies, I'm iterating over the union of the adjacent radials and the diagonal radials, just one fewer control flow statement. I personally prefer to limit my methods to one control flow statement. May sound extreme, but I think once you start doing it, you never go back. Generally speaking, my methods will have an if, or maybe an if else, or a for each, while, but only one of those things. I don't like to have more than one. If I have more than one, I pull methods out. I extract methods until I only have one. And they're, you can get even a little more declarative. No looping at all. How about that? So now on to what I was mentioning, which is that we need to have the case for moving backwards or down, however you want to think of it, the negative x and y adjacent directions. So I'm going to say that for 3,3, we're also going to want to return 3,2, and I'm going to type out the appropriate setup condition with 3,3 being passed in, and the default board size, and then I'm going to assert that we have the 3,2 board coordinate coming back in the collection. And we're not going to, so I will have to go and implement the logic for this to happen. So how did I draw the line going and looking at this method between doing 2 and doing all 4? Well, felt like maybe I was getting a little ahead of myself, so I stopped at 2, frankly. You got to do what you're comfortable with, really. Simplest thing, how are you getting yourself to the next step? You're balancing having an amount of coverage that you feel good about to get the problem right, and between, moving along at a good pace. You don't want to spend all day writing, extremely obtuse things. So, it's kind of a matter of practice. It becomes a matter of preference. And it's a matter of what you're comfortable with. How confident are you that you're going to get the problem right? Because if you bite off more than you can chew and you get it wrong, that's rework. That's the whole thing TDD tries to get you away from. You can move along and make positive progress instead of this thing where you write 20 methods at a time and spend an hour doing this, and then you fire up the application and run it and everything goes wrong, and there you are in the debugger. You're trying to get away from that kind of nonsense with TDD. So if you're biting off more than you can chew and things are going wrong, then you're in debug mode, you're in what's wrong mode. But if you're doing the simplest thing you can to get things to work while keeping the other tests passing, you're almost never in what went wrong mode. You're building on this series of wins. You write a test and you're expecting it to fail. That's your hypothesis, and it does. And then you have a pretty good idea what to do to get it to pass, so you do that. Your new hypothesis is this will fix it, and then it does, and then you win. And you just keep building on that. So don't stop yourself from winning. Don't bite off more than you can chew. Do the simplest thing you can do to get the test to pass, with simple as measured by, are you going to get it right? So I'm doing a little bit of refactoring here. I noticed that in multiple methods here I was defining this collection of coordinates that would be returned from a starting position of 3,3. So just another piece when everything's green of duplication that I can eliminate. So now I have a series of single line tests, which is nice, and I'm going to have another one here in order to tease out this last case. So I'm going to assert that in the moves from 3,3, there is one with the coordinates 2, 3. This fails, forcing me to go back in and write in the very last case. And I said I never copy and paste this Control-Enter thing I do here in CodeRush to duplicate the line. I'm cheating a little bit here, I won't lie. So, you know, all things that are matters of pragmatism, in my opinion. So I do the generally strict avoidance of copy and paste to force myself to feel pain, to force myself into writing better code. But, you know, sometimes typing a very similar line that you don't necessarily intend to refactor. You know, trade-offs in all things. So the last thing I'm doing here is I don't believe I have put any sort of guard condition on what I'm doing. So what I need to do is make sure that we're not returning any nonsensical board coordinates. So I'm going to use the OR condition here to broaden the scope of what I'm doing a little and say, you know, is anything being returned here with a board coordinate that is where either component of it is 0? And I'm failing. So now I'm just going to tack a where clause onto the end of this and say, is coordinate valid for board size, and supply the board size. And now we are not getting back any 0 coordinates, garbage coordinates. So I can go in here and say that the king class is now successfully implemented. And now I'm going to talk about something I will do later, which is, if you're a fan of chess, talking about how there are limitations and special moves of the king. So right now there's nothing to stop the king from moving through check. And there is nothing to allow the king to do the special case of the castling maneuver. So I'm going to take out the king and I'm going to put it in its own class in this production folder. And I'm going to use my little naming trick here. And finally, I'll get the file naming correct and then probably eliminate these extra usings with the aforementioned keyboard shortcut. And then I'm going to go back over here and maybe take a look at some things I can do to think about readability. Always when I have a method like this, I'm starting to look and think like, okay, if somebody else is coming along, what's this going to look like? It's a lot of things, you know, union and where clause and all that. So let me define a little bit of good method naming here to indicate what declaratively is going on. So one square of moves is get radial adjacent union with get radial diagonal. So I can return the one square away moves where it is valid. Now another subtle thing that I'll mention real quickly here before I wrap up is in code coverage when you're using the enumerable yield with link, you might see a uncovered line at the end. It's often good to go and do a to-list or something to get that to be enumerated. And with that, I'm going to leave off, and I will see you next time in the series.